Hello everyone, welcome to this video. In this video we have to prove that in any group an element and its inverse they have the same order. We first of all assume that our group is represented by the symbol capital G, and from this group if we take some element small a from it, right, we assume that the order of this element A is n. That means a raised to power n is equals to e, such that n is the smallest positive integer, where what is this e? It is the identity of the group. This thing is known to us. Then we have to prove that the order of A inverse is the same as that of order of A. So that means we have to prove that the order of A inverse is exactly n. So for that we need to prove that n is the smallest positive integer such that we have A inverse raised to power n as equals to e, correct? Okay, so here we consider that A inverse raised to power n is what it is. You can shuffle up because you can use the exponent law like this. A raised to power m raised to power n is A raised to power mn, which is further equals to A raised to power n raised to power m. So using this result here, you can write this thing like this, right? Now the value of this thing is e, you know that because it is given to us. So and the inverse of identity is identity itself. So from here you obtain the value of A inverse n as equals to identity, correct? So one part of the proof is done. Now we have to show that this n is the smallest positive integer such that we obtain this condition, correct? So if n is the smallest positive integer of the kind, then we are done with the proof. If it is not, that means there would exist some other integer such that that integer will satisfy this condition. Let's call that integer by m. This integer m is less than n and it satisfies this property. So therefore, if we consider A raised to power m, you can write A as the inverse of its inverse. There is no issue. That is what I have done over here, right? So this is equal to this. Again, using the exponents law, we can exchange these two powers. So it would be like this, and the value of this is equals to e from here. And the e inverse is what? It is e again. So that means A raised to power m is equals to e, and where your m is less than n. However, this is a contradiction. Why? Because we know the order of A is n. If the order of A is n, right, which is, and the integer n is obviously greater than m, and we again get this condition for that, so that would not be possible. It would lead to contradiction to the definition of order of A, which is n. Hence our supposition that m less than n is a positive integer such that A inverse m is equals to e, this is incorrect. There cannot exist any integer less than n such that we have this condition. Hence it proves the result that n is the only smallest positive integer such that we have this condition true. Hence it becomes the order of inverse of A. Hence the inverse of A and the element A itself, they both have the same order, which is n, and this is what we wanted to prove here, right? So I hope you understood this proof well. That is it for this video. Thank you for watching.